Now we need to do the same thing with the cadence light. And so, go where I have this direction system. And so we need to get a audio transformer with cadence light. We need the AC voltage source, resistors, inductors, and capacitors. And so we need to get this part, and it's a control value, and it's a transformer rated, this thing. We plug it and bring it on the screen, and now with the cadence line, for some reason, they use the reciprocal turns ratio that I'm using, and so let's click on this. Double click it to bring up this table. So they use the primary to secondary turns ratio, which most people would not use. They would use the secondary to primary turns ratio. So since the turns ratio is 3, we make this 1/3. And then leakage inductance, take it from the default value, the really small ones, magnetizing inductance, leave it alone. Primary winding resistance, reduce it to close to 0. Secondary winding resistance, reduce it close to 0. Then you perform the same thing, AC simulations. We click on simulate, go up here to analyses, AC. Go to output, I have it set up here to plot the input and output power function frequencies. And the output power will be plotted across the load resistor RL, which is V5 squared divided by RL. And then this is the input current times the cosine. And here we don't have to change from degrees to radians. It's set up for radians. The cosine of the phase of the current flows to the load source, V1. You click on simulate, and you get this plot. And of course, the angle on the power is totally meaningless. So let's get rid of this one. And so we get this as a plot of the input power versus frequency and the output power versus frequency. Finally, we come up to
Professor?
Yes?
Oh, we have to put a press also on that, correct?
Yeah, I know. Go fast, so I didn't put curves on there. See if I start up Mathcad, it's the one thing I forgot to start. We'll take a brief look at it. You just want to analyze the circuit using Mathcad using the equations that we go over. And plot the voltage versus frequency and the input and the output power as functions of frequency. So go over here, go to plot the direction system. Got that. And so these are just the equations, and J is square, minus 1, and so forth. This is the R. So then the Q's make it all over R. This is the impedance, the inductor, the impedance, the capacitor. This is V sub I as a function of F. The input current is a function of F, the secondary current. The output power is either the voltage squared over R sub L, or the secondary current squared times R sub L. The input power V times I on the cosine. Set up for radians. You plot it. You get this as the voltage is a function of frequency. This is the magnitude. This is the phase. This is the input and the output power. Now, one of the things you can do with Mathcad is put a cursor on here to check it at various points. If I right-click this and click on trace, I can put the corner right here. And it says at that point, the X value is 33,926, the Y value is 0.38986. Now, this week in lab, Michael Lauder came to your lab to talk about your second writing assignment, which is the design of a notch filter. Some of you did what you were supposed to do, which is after you talked for about an hour, stay in there and make your experimental measurements. For some sections, however, when I was walking down the hall, I was almost stampeded to death by your running out of the lab at the end of this lecture. So when are you going to make the measurements? Okay, you've got to make them sometime. And so the lab isn't in use on Monday and You can also work in the open lab for ECE 3042, which is in C353. You need a part, in particular capacitor, etc. You can ask